Imagine standing under a starry sky, the moon glowing brightly above you. Its surface, a patchwork of shadows and light, tells stories of ancient impacts, cosmic collisions, and a history that stretches back billions of years. Each crater, a bowl-shaped formation etched into the lunar landscape, whispers secrets of our solar system's tumultuous past. These scars, formed by asteroids and celestial bodies colliding with the moon, are more than just fascinating features. They're vital clues that help us understand not only the moon itself, but also the evolution of our entire cosmic neighborhood. Now let's dive into the fascinating world of lunar craters. Picture this. The moon has no atmosphere, no protective shield like Earth. So when a meteorite comes barreling in from space, it doesn't just fizzle out in the atmosphere like it would here. Instead, it crashes into the lunar surface, leaving a permanent mark. This is why the moon's surface is littered with craters. Approximately 31% of its visible side is covered with them. Each impact leaves behind a unique scar, telling a story of the solar system's violent history. The journey to understanding these craters began centuries ago. In the 17th century, astronomers like Giovanni Riccioli took it upon themselves to map the moon. His 1651 lunar map laid the groundwork for the crater naming system we still use today. Can you believe that? A map drawn over 370 years ago is still guiding our understanding. Fast forward to modern times, and we have sophisticated tools like NASA's Lunar Reconnaissance Orbiter, or LRO for short, which captures high-resolution images of the moon's surface. With this satellite constantly circling our celestial neighbor, we're able to create detailed maps that reveal the topography of the moon like never before. But it doesn't stop there. The Lunar Orbiter Laser Altimeter, or LOLA, uses laser technology to measure the moon's elevation. Imagine sending a laser beam down to the moon and measuring how long it takes to bounce back. This is how we understand the heights of mountains and the depths of craters. And radar mapping? That's another layer of discovery, allowing scientists to peek beneath the surface and uncover hidden structures. All of these efforts culminate in creating three-dimensional models that give us a comprehensive view of the lunar landscape. Now, why does this matter? Well, mapping the moon isn't just for fun. It's crucial for future missions. These global maps help identify potential landing sites for astronauts, study geological history, and even track new crater formations. Just think about it. Each crater we study gives us insights into the moon's age and geological evolution. It's like reading a cosmic diary. Speaking of craters, let's talk about some of the most famous ones. Amateur astronomers have a blast observing these formations from Earth. With a medium-sized telescope, you can spot around 50,000 craters. Two of the most frequently observed are Copernicus and Tycho. Copernicus spans an impressive 93 kilometers in diameter, while Tycho measures 80 kilometers. The best time to observe these craters is during the moon's first quarter phase, when shadows accentuate their structure, making them pop against the lunar landscape. If you're keen on diving into lunar observation, you don't need to break the bank. A refractor or reflector telescope with an aperture between 70 and 150 millimeters, or even high-powered binoculars can do the trick. And don't forget about lunar filters. They help enhance contrast and reduce brightness, making your viewing experience even better. Some enthusiasts even attach cameras to their telescopes to capture stunning photographs of the lunar surface, turning their observations into beautiful art. But the story of lunar craters doesn't end with the past. Crater formation is still happening today. The LRO satellite keeps a vigilant eye on the moon, and in 2013, it detected a newly formed crater about 18 meters in diameter, the result of a recent meteor impact. Scientists estimate that around 180 new craters are created on the moon each year. Most of these impacts are small, making them tricky to spot from Earth. But with space-based monitoring, even the most subtle changes are tracked. This ongoing study of new crater formations is vital for understanding the moon's geological activity and the movement of asteroids in our solar system. And here's an interesting twist. Some polar craters are believed to contain up to 100 million tons of frozen water. That's right, water. This could be a game changer for future lunar missions. providing essential resources for drinking, oxygen, and even hydrogen fuel. Imagine astronauts setting up a base on the moon, tapping into these frozen reserves. It's not just science fiction. It's a step towards making human presence on the moon a reality. As we continue to explore the moon, we're not just uncovering its past, we're also preparing for the future of space exploration. The craters are not just scars, they are valuable sources of information, helping us understand the history of our solar system and ensuring the safety of future missions. The moon is a reminder of how interconnected we are with the cosmos, and every crater tells a story that deserves to be heard. So next time you gaze up at the moon, take a moment to appreciate those craters. They are windows into the past, guides for the present, and beacons for the future. Let's keep dreaming and exploring, because the adventure of understanding our universe has only just begun. Buckle up, fellow space enthusiasts. There's so much more to discover.